Today we're going to be doing Module 2, Topic 3, Lesson 2, called Double the Fun, using graphing to solve systems of equations. Our goal for today is we're going to write a system of equations to represent a problem context. Some essential questions we have for today. You have examined different linear functions and solved for unknown values. How can you solve problems that require two linear functions? How many solutions exist when you consider two functions at the same time? To start us out, we have a situation called ticket tabulation. The Marshall High School Athletic Association sells tickets for the weekly football games. Students pay $5 and adults pay $10 for a ticket. The Athletic Association needs to raise $3,000 selling tickets to send the team to an out-of-town tournament. Number 1, they ask us to write an equation to represent the situation. Well, before I can write this equation, I am first going to identify my x and y variables and what they represent. My x variable represents the number of student tickets. And my y variable represents the number of adult tickets. So for this first equation that we're going to write, we are going to write how much it is for a student ticket, how much it is for an adult ticket, and how much in total their goal is. So their goal is to raise $3,000. I also know that student tickets are $5 and adult tickets are $10. So I get the equation 5x plus 10y equals 3,000. For 2.1, we're going to analyze the graph from an equation in standard form. Consider the goal of the athletic association described in the previous activity. Let x represent the number of student tickets sold, and let y represent the number of adult tickets sold. Written in standard form, the equation that represents the situation is 5x plus 10y equals 3,000. This is the equation that we just created. One efficient way to graph a linear function in standard form is to use x and y intercepts. You can calculate the x-intercept by substituting y equals 0 and solving for x. You can calculate the y-intercept by substituting x equals 0 and solving for y. So let's first find the x and y intercepts of the equation below. So for our x-intercept, I can substitute 0 in for y. So I have 5x plus 10. Instead of putting a y, I'm going to substitute that in for 0 equals 3,000. So really I have 5x plus 0 equals 3,000, which means 5x equals 3,000. Then I need to divide by 5 to isolate the x. So x equals 600. That means my x-intercept is at 600, 0. My y-intercept, I'm going to do the same thing that I just did, but instead of substituting in 0 for y, now I'm going to substitute it in for x. So I have 5 times 0 plus 10y equals 3,000. So really I have 0 plus 10y equals 3,000, which is really 10y equals 3,000. Then I divide by 10 on both sides. So y equals 300. So my y-intercept is going to be at 0, 300. So now that I know my x and y intercept, which is at 600, 0, and 0, 300, I can graph those 2 points on my coordinate plane to graph this equation. Another way that you could do this is you can convert it to slope-intercept form and graph it that way as well. So if I were to graph these 2 points, my x-intercept is at 6, 0, my y-intercept is at 0, 300. So I'm going to connect these 2 points to make a line that looks like that. Number 2, I'm going to determine the domain and range of each. So this first one says the mathematical function. That's just looking at the function as is altogether. So my domain, remember domain is all possible x values. If we look here, there's an arrow on both sides of my line. That means that they're going to be going on forever. So my domain will be all real numbers. Then I need to do my range. Again, range means all real numbers, or my range means all possible y values. If I look at my function here, they both have an arrow on both sides. So that means it's going to be going up and down forever for my y values. So my range is also going to be all real numbers. Then we get to B. This is the function modeling the real world situation. So that's the important part here, the real world situation. So in the real world, it is not possible to have a negative number of student tickets or a negative number of adult tickets. It's not possible. So what that means is, for the real world, we are only going to be looking at the positive x and y values. So I'm only going to be looking in this first quadrant here. So, my domain for the real world. My smallest domain value is 0. My largest domain value is going to be 600. So my domain in the real world situation would be 0 is less than or equal to x, which is less than or equal to 600. My range in the real world situation. My smallest range or my smallest y value is 0, and my largest y value would be 300. So my range is going to be 0 less than or equal to y less than or equal to 300. In activity 2.2, we're going to determine the solution to a system of linear equations. So we're adding on to the story that we've already been talking about. It says the athletic director of the Marshall High School Athletic Association says that 450 total tickets were sold to the home game. Number 1, they want us to write an equation that represents this situation. Let x represent the number of student tickets sold and let y represent the number of adult tickets sold. So, I do not know how many student or adult tickets were sold. I do know that altogether 450 tickets were sold. Since I don't know the exact number of X student tickets and Y adult tickets, I can just use their variables to show that number. So I get the equation X plus y equals 450. On this next part, this is the graph, the line that we already created in this lesson for the first equation. What we're going to do now is we are going to graph the second equation. So they would like us to identify the x and y intercepts. So if I have x plus y equals 450, if I plug in 0 for x, this will tell me my y-intercept. So I have 0 plus y equals 450. So that really means y equals 450. So this ordered pair would be 0, 450. So that's going to be right around here. Then I do the same thing. So I have x plus y equals 450. And now I'm going to substitute in 0 for y. So I have x plus 0 equals 450. So that really means x equals 450. So this ordered pair would be my x-intercept, 450, 0. So it'll be right around here. I'm going to connect these 2 points as best I can. So something like that. And you may notice they intersect at this one spot right here. So number 3, it says if the athletic association reached its goal of $3,000 in ticket sales, how many of each type of ticket was sold? Is there more than one solution? Well, if we look at our graph, okay, it looks, about close to 300 tickets for students and about 200-ish adults. Again, there's human error here, so it might not be exact. But I do know there's only one solution. How do I know there's only one solution? They intersect at one point. Number 4, they want us to use technology to locate the exact location of the intersection. So the way we do that is we take our 2 equations, we can convert them to slope-intercept form, and then we can graph them in our calculators, either the yellow one or the Desmos calculator. So if I have 5x plus 10y equals 3,000, I want to get y by itself. So I'm going to subtract 5x on both sides. So I get 10y equals negative 5x plus 3,000. Then I divide by 10. So I get y equals negative 1/2 x plus 300. My second equation, I have x plus y equals 450. I subtract x from both sides. So I get y equals negative x plus 450. I will take these 2 equations here and graph them in my Desmos calculator. So if you look here, I've already graphed them in my Desmos calculator. And the cool thing about Desmos is I can just select where they intersect and it gives me the ordered pair. So the ordered pair is 300, 150. So this means 300 student and 150 adult tickets. That's what that ordered pair means. These two numbers of tickets would give us the $3,000 total that we want. It would also give us the 450 total number of tickets sold. All right. On activity 2.3, we're talking about systems with no solution, one solution, or infinite number of solutions. So Marcus and Philip are in the robotics club. They are both saving money to buy materials to build a new robot. Marcus opens a new bank account. He deposits $25 that he won at a robotics competition. He also plans on depositing $10 a week that he earns from tutoring. Philip decides he wants to save money as well. He already has $40 saved from mowing lawns over the summer. He plans to also save $10 a week from his allowance. Write equations to represent the amount of money Marcus saves and the amount of money Philip saves. So let's talk about Marcus first. So Marcus saves $10 a week, but he had already deposited $25 from his earnings or winnings at a robotics competition. Philip, he also saves $10 a week, but he had saved $40 from mowing lawns. So here's my two equations here. So using our equations to predict when Mark and Philip will have the same amount of money saved. Hopefully you noticed that both equations have the same slope. And hopefully you remember that means that they are parallel, which means that they will never meet. They will never touch. So what this really means is that there will be no solution. There will be no value of x and y, a point that the two lines will meet. We kind of already talked about this. How do the slopes compare? They have the same slope. That means parallel, they're saving the same amount of money every week. And B, it says how do the y-intercepts compare? So they have different y-intercepts. Philip's y-intercept is a greater number. His starts higher. He started with more money to begin with. And since they're saving the same amount every week, that means Philip will always have more money. I decided to skip number 4. On D, we're going to graph both of these equations. So for Marcus, the equation was y equals 10x plus 25. So I know my y-intercept is 25. That's going to be my first point. And then my slope is 10. That means for each week, I'm going to go up $10. So I started at 25. After week 1, I'm going to have 35. Then 45, 55. And then that trend will continue for Marcus. I'm going to put an M for Marcus. Philip's equation was y equals 10x plus 40. So my y-intercept is 40. That's where I'm starting. And he is also going to go up $10 every week. So this will look something. That's Philip. So if you notice, the two lines are running alongside each other. They have the same slope, same steepness. They will never touch. So this means that they have no solution. So what do we notice? They are parallel. Does this linear system have a solution? There is no solution. They never meet. The next scenario is talking about Tanya. You can also complete this. It's the same concept. We're comparing Tanya to Philip.